Oh, we are starting out in rare form. Ah, yes. Okay, I was checking the checking to see if I exported the stream to YouTube yesterday. I think I did, but I think I also neglected to update the stream data. Today's stream should be 559, not 558. Let me correct that, but the archive will not be correct. Okay. There we go. You were enjoying the music? Well, I can just shut up then, you know. Or we just bump it up a little. Yesterday was a running day. Today's going to be arms. Arms, chest, back. I never do abs, though. I should do abs every day. I just don't. It's one of those things, right? Exercise. And I am not a fan of exercising. Morning, Xenocron. And my neighbor, much older than me, had these great words of wisdom. My neighbor said, would you rather hurt because you're not doing something or because you did something? Would you rather hurt because you're not working out or because you are? Because as you get older, and dare I say, I might be getting older every day. Yeah, you'll have more aches and pains. Okay, so I'm going I'd rather hurt because I'm doing something than because I'm not route. Yeah. Actually, hello world. Yep. And good morning. And thank you for the follows. Let's see, we have Izzy Star XD. That's one name. I just added a space in there. Not sure why. Rizadex, or is that Rizadex? Welcome. Welcome. You're right there. Yeah, man, it's life, you know. Let's see, where's our terminal? There it is. Hello, buddy. How you doing? Okay. You know what? Your Docker images at work aren't dockering? What? I've never verbed Docker to Docker. Dockering, Dockerizing. They haven't docked? They're syncing. Okay. You're trying to Docker and they don't. Let's see if we can get the web piece working. And so we're gonna jump straight-ish into this. Oh, the function. What should we call this? Initialize? I don't know, how do we expect to call this from main? Right, so main we will either... So what does this look like? We have Bastion here. We can just call Bastion, right? Because it's all working with globals. So we could just say, you know, web, do your thing. Or we could set up a little bit inside of main and then ask web to do its thing. Or we can be explicit, like web, you know, have some sort of Bastion supervision here. Art supervisor. Something like so. And we could always add some data to this eventually. What would that look like over here in main? Oops. Supervisor, right? We don't get a return. Or maybe we could. Let's see, let's go back to the docs on Bastion. I would like to have Bastion, or rather the web crate, start a supervisor tree. The web would just call Bastion supervisor. We configure the supervisor. Okay. Ah, we want to return the supervisor ref. That's what we want. Okay. So that we can stop it, etc. That makes sense. That makes a lot of sense. My emotes work? Yes, they are. Okay. But not that one. My 7 TV emotes are borked. Yeah, they're gone. Anyhow. Okay. Bastion supervisor. Let's do that in the web portion. Remembering my helix takes a moment. Supervisor. We give it some sort of init, and this is going to be a closure. And we get some sort of context at this point, don't we? I wish I knew how to scroll this little inner window, which I don't. Let's take a quick peek at that. Helix, scroll pop-up. Up, down, not scrolling pop-up documentation. Okay. So if we use Control K, or it's just Shift K, then we can get the docs on that. Let's try that. Pull up and down. Oh, it does work. Okay, and oh, the Vim is strong in these hands. Oh, the training. Okay. And if we do Control D, oh, it does work. So it's Control up, and Controls U and Control D. Got it. Got it. Okay. I wonder what the SP is. Supervisor SP something. With strategy. I think on the website it's going to be 1-for-1. Because if any one of these children die, that's fine. We don't have to close all of them. One for one. And we need to import this. Mismatched types. No. All right. So we have to return result. Supervisor ref. Got it. Supervisor ref or unit. Okay, so we have our start supervisor, but we're not doing anything with the supervisor. We should do something with that supervisor. Now, what we would like to have happen in the website is that we start wiring up Axum. I would like to be able to start web from different places for testing, and so the supervisor piece is going to be one way of starting it. We should have some other way. So we will try to extract as much as we can out of these two different ways of starting it and having a common core. Everything worked yesterday. Today it's broken. You're gonna get Nix running? All right. You boot up a child on the supervisor. That's just an actor that starts up the other children for each connection. And just message that one actor that TCP streams. Oh, interesting. You are upset with yourself. Oh dear. You bought a new camera and it shipped to your old place of employment. No. That's not the worst thing though. Right. Hopefully they sign for it and all that jazz, right? So there's going to be a record of it actually going there. That should be, albeit awkward, not the worst. The worst would be like, I shipped it to my old place of residence, right? Where there, and like sketchy people have moved in. That would be the worst. Is Load supervisor equals that. Children. Oh, look at this. Creates a new children. Oh, for like a week. Oh, your patience is very low. Oh, dear. All right. So, you could boot up a child on the supervisor. It's just the actor that starts up other children. Okay. Now, this could also be named, couldn't it? I thought we could have named things with this. Explore. Yeah. Where's the docs? How do we name it? Spawn. You can name children groups, so you can do basically an any cast. Wow. Oh, that's neat. That's neat. Okay. Yes, that would be useful for announcements the server is shutting down, right? So we could take that into account. Then you can also up the redundancy without worrying about something happening twice. Ooh. Wow. Okay. That's cool. That's really cool. Okay, but with the supervisor, let's see. Let's say we start up a child in it. Here we give it a context. How do we set up... How do we set up the identifier, the ID? When we go to send a message, I expect that there's going to be some way to set that up. Oh, on the children object. Oh, okay. Let's go look at that. Your lesson learned. Remove those old addresses from shopping accounts. Yes. Oh. Okay. Can you have my email address? It's okay. Like, you're very forward. Wait, we're not even on a first name basis yet. Oh, with name, I see. You can reach me in Discord if you want to reach me. We can take that offline. With exec, okay. So we can give it a name, etc. Hands a supervised element to the declared dispatcher by default. Interesting. Supervised elements aren't added to any of the dispatcher. Wow. Okay. And then you can address a dispatcher group via anycast. Oh, wow. Wow. And welcome. Happy Thursday, Wahid Malik 108. right? Sarcasm, yeah. Okay. That's funny. It's funny because my information's not like but a click or two away. So distributor, gotcha. The distributor to the children. Okay, and how do we create a distributor? Let's go look at that. Bastion. Distributor. Provides the methods that we will allow to send messages and add remove actors to the distribution list. Alright. Ask everyone, request, tell everyone, tell one, unsubscribe. Oh, this is useful. So basically we create one of these, right? And we can do that in this setup, right? We could just say start. And then inside of here, we set up the web distributor. Now, what is the purpose of having the sockets supervised, though? So that we can... Oh, well, because we need messages. Right? We need a way to be able to pipe messages from one side to the other. You almost got stuck in another country because when they asked for your birthday, you gave them the wrong one. I forgot the format was different there. COVID test couldn't have matched your information, and the airline wouldn't have taken it. Wow. Wow, wow, wow. And these groups are addressed by the name. Okay, so basically we have individual children supervised so that we can message them directly. Then we have a distributor. We attach these web children to the distributor so that we can anycast or ask any one of them information. Got it. Is there a large overhead in using named children versus having references to children? I imagine there's a lookup, but is it going to be slower or faster than a lookup that I create? I doubt. Like, it's probably going to be on par, right? Distributor. Oh. Want a named one. Create a new distributor to send messages to. Web distributor or web or web clients, web connections. Web clients might work. Doing that without distributors is just horrible. Oh, I see. If you up the redundancy, you need named groups. That's a great point, Glitch. Thank you. And what shall we do with a distributor? Let's see. So once we have one, we can associate other things with it. We can have a, let's see, ask everyone. We can make it named. We can request something from a distributor. Oh, I see, children. Then we can create with distributor. Yep. So here they're creating one. Will we have to keep a reference to it, or can we get the same one back? Subscribe, tell everyone, tell one, unsubscribe. I see. So it could subscribe to the children itself. You get the same one if you create it with the same name. Perfect. Okay. Let's put that name. Some static. Web client's distributor name. Okay. Do I have a public design doc somewhere? I do not. This is kind of in my head at the moment, but we can talk it out. This is the closest we have to a public design doc. Yep, we were doing a little bit of research. We explored Axum Live View to see if it would work for what we're interested in, and I think it will. Bastion looks so close to the frameworks I'm used to in Erlang that I have a good sense of what it's capable of. And pretty much the game is going to be that Live View, Bastion, some ECSs, and then a couple other little bits, but it's not going to be crazy. I got paid 2 cents more this paycheck compared to last. You can say I'm moving up in the world. You got your 2 cents back. I see what they did. In terms of the design, we'll have our little main right down here. It will initialize Bastion, and we have these Bastion, I forget what they're called, supervision trees. I don't know why I call them BC, Bastion context, whatever it is. And so we would start one up for the web view to be able to message these individual pieces, and the web view would be able to then update the live view and send it back to the client for individual pieces of the page. As an upscaling strategy, I imagine we don't need it for the web piece, but we might need it for, let's say, the world piece or some of the other portions. That's cool, though. Okay. Now, I don't remember. You're going to have to forgive me for a moment. Tutor. I went through this the other day. Deletion, saving a file, opening lines, motion selects. The thing that I'm missing is, like, select everything within these two boundaries. And I know we went over that. Well, we didn't. I did with the tutor here. Select extend mode. No, I got that. Selecting lines, fine. Recap. Copy pasting text. Yeah, multiple cursors, which is awesome. I like their multiple cursors. Registers, okay. They're Vim-like. Jump list. No, where was it? Indenting lines, no. The aligning sections is just cool. And so, like that's neat, but not useful at the moment. Yeah, you can select it via regex, but that's not what I'm looking to do. So you can select the line, filter the piece out that you want in the line. I am missing that piece. All right, I need to look that up. Helix, select within. Selection manipulation. Bring selection to line bounds, join lines. No, no, no. Keeps. Search minor modes. Migrating from Vim. All right. Also see Kikuin's migrating from Vim and Helix. Delete a word. The last line, go to this. Okay, we're almost there. Jump to matching bracket. Oh, that one's useful. Okay. Autocomplete. Control X. That Control C comments, Control X autocompletes. Interesting. Interesting. I'm not seeing it. Like I'm looking for like the VIW, right? Oh, that's... Oh, I didn't know those. GL and GS. That's useful. Oh, HL. I see. HLS. Okay. Well, I didn't get what I wanted. But look at that. Okay. Can go to the beginning and end of a line now. Oh, I'm so proud. Okay. I'm using MM already. Am I... Oh, I've missed a semicolon here. This is a terminal-based editor. Yes. This is called Helix. That's not Vim. It is not Vim. This is Helix. Go. Okay. You still use a lot of mouse in your text editing workflow? Yeah. So far, I like Helix. I like that it has LSP support. I really like that. I like that it tries to explain things as you go through it. The tutorial is rather nice. And the multi-cursor mode, I think, is really great. I like where they're going with that. In this case, if I wanted to go here, In this case, I would usually do like in Vim it'd be a VIW, right, or a VI double quote. Select inside of the double quotes, right? But we're not doing that. And so I can either just go into extended select mode in Helix, change it like that, but I like to be anywhere inside of the word. Right? And there isn't a way that I've seen to be able to select that other than like kind of go back and forth. You work doing custom development for an ERP P21. You hate this DB so much. Oh dear. Yeah, we need a smaller name for that. Okay, so we will have this. Oh, and thank you for all the follows. AndKit 3009. Uhu JC, thank you. Rizadex. I think I probably thanked you twice now. But cheers. Yeah. I also like the mouse support in it. Seems very nice. Ooh, there's a new version of Kitty, but I'm not using Kitty. Like the linking table should have foreign keys to go to the other tables. It's linking. Nope. So ORMs don't know how to traverse it. Alright, so now in this case, we are going to have... Can a supervisor have a supervisor? I feel like maybe we... Let's see, in this case... Right, where's our whiteboard? Where's our whiteboard? Here. Okay, when we're thinking about this web thing, right, when we start it up, we have a supervision tree. And what does that look like? That looks like, you know... We have the distributor. Okay. And this will be associated with a number of children, right? It feels a little different from Erlang, right? Their distributor, but that's fine. The OTP system in Erlang is just phenomenal. The Open Telecom platform, I think it's really good. But in this case, we're going to have a supervisor. All right, that's an S. Supervisor. And the supervisor, in this case, we don't have any socket children yet, so it's just going to have a child. And the responsibility of this child is going to be adding other children to potentially some other supervisor or the same supervisor. And that's where I'm stuck, because we could have a second supervisor, right, for all of the sockets. That's a socket, S-O-C-K. Right, and this child here could receive the notices that, hey, you know, we got another socket. Add it to the other supervision tree. So so it could receive a message and then add it to this supervision tree. And which means that we could treat these two supervision trees separately, right? This one here could end up having multiple instances of this child, this little worker child, in case we get, let's say, an influx of sockets suddenly. Who knows, right? How would we set that up? Let's try to go this route. Okay. Oh, and then the distributor here at the top would be then associated with each one of these as well, of the supervisors. socket children. Okay, so given the supervisor, this one, I think we can have a strategy of 1 for 1. How do we also set up? Nope, getting there. The redundancy. Let's go back to supervisor. Children? Oh, what's ID? That gives us a Bastion ID. Huh. Okay. That's set up on the children with redundancy on the children. Okay. Sets a number of elements this children group will contain. Got it. Why was the polearm master not paid for their services? I don't know why. Each element will call the... Let's see. Because he's a freelancer. Oh. My kids started hitting me with dad jokes yesterday, and it was interesting. Oh, I have some to share. Yeah, they found some on a website and just started sharing. Let's see. I just broke up with my mathematician girlfriend. She was obsessed with an X. I asked my date to meet me at the gym, but she never showed up. I guess the two of us are never going to work out. Yeah. Okay. Redundancy. Sets the number of elements this children group will contain. Each element will call the closure passed in with exec and run the returned future until it stops. Okay. Panics or another element in the group stops. Okay. Oh. Okay, so let's do this. Supervisor.children. And now we have, oh, and we can do Control D to look at the docs. So we have this children object, and then we can call with exec, and we can call with redundancy, etc. Oh, yeah. I'll let them know that you appreciated those. Take children there, and then, oh, Helix, I like that. You formatted that correctly. Thank you. Children dot with redundancy. 3. I don't really have 3,000. Yes. I misspelled that. Oh, we can do with dispatcher. No, we want with distributor, right? Oh, this is not the same one. This is... Oh, let's change this. We need 2 of these. Okay, we need 1, which is the web client's like startup, like the thing that we're creating. Trying to get to the blackboard here, right? What is this child called? Web client's bootstrap? I don't know. Web clients group. Okay, now this one here, web clients distributor. This web client's bootstrap, so we'll be sending the sockets to this bootstrapper. So we need to use the web client's bootstrap here. So we're using that distributor. Oh. We could just give them a name and send directly to them. And because we have redundancy, it basically acts the same as... So instead of having a distributor for that, we could just have web clients bootstrap. That's their name. You have to chain these calls. Children, oh, okay. Okay, we can do that. X. My X finger keeps hitting X because Vim. Okay. Thank you. I'm going to change this one to group. Let web clients not sure if you can address them by their name. What would be the use of the name then? Let's see. So that's the name of this children group. Maybe for logging? I see. Right, so let's continue with the distributor then. And we should then choose a different name. Yes. With distributor web. Create that. Change this name. Let's see, web. A bootstrap will work. Okay. Getting closer. Now we need to exec something. So I returns a future. Okay. With result of unit. Receives a Bastion context. Okay. Sets the closure taking Bastion context. Returns a future that will be used by every element in this children group. Okay. With exec, context. I like CTX better. CTX dot. No. Oh yes. Return just a async block. That's really simple. That's fairly ergonomic too. Okay. Send a message, okay, etc. We probably want to receive a message at this point. But I don't know how to receive messages in Bastion yet. We'll basically loop forever while receiving these messages. We'll have our loop. We'll say, use the message macro for best performance. Okay. Message macro. All right, so we'll use that. Don't know how yet. We'll get there. Where's the message macro? Bastion, macros. Oh, look at all of these different macros. Oh, look at this beauty. Matches a message. Oh, and Damco Dev, thank you for that follow. Oh, you know what? It was cold in here yesterday, so I turned the heater to like point at me, and it's just been drying my eyes out. Just having that warm air just kind of wash over my face all day. Oh. It was nice and warm when I needed it, but then I left the heater there. You're just confused right now. Stream, call, and debugging at the same time. Matches a message as returned by a Bastion context receive or Bastion context try receive with different types. Each case is defined as okay, an optional ref, which will make the case only match if the message was broadcasted. All right. a variable name for the message if it matched this case, a colon. Okay, so your ref name colon, a type that the message must be. Okay. An arrow with an optional bang between the equal and the greater than signs. Interesting. Which will make the case only match if the message can be answered. Oh, so this is the magical answer. Yes, I can answer you. Code that will be executed if the case matches. Gotcha. I do not think we have to answer these, so we'll use just regular fat arrow. Not the kind of shebang fat arrow. Okay. And their lovely example. Message. Okay. Context receive. And that, wait, that's the optional ref? No, oh, here it is. Optional ref. Then you have the variable name. Okay. A colon, then the type. Okay, this just looks very rusty. Okay. Why would we use a ref here? With messages, are they not just passed in? This is an implementation of the actor model in Rust. Yes, and very closely modeling the OTP platform for supervision trees and message sending to ensure the message is a broadcast. Oh, I see. Okay. Only, okay. I see. So that's basically if it's broadcasted, because it makes me think that, okay, I'm just going to hold a reference to this as opposed to, I don't like the name on that. It could have been maybe better chosen. Elixir is Erlang is not your jam. Now, just to be clear, like Elixir is fantastic. Erlang is fantastic. They're in their own ways. Erlang is a pain in the ass to refactor because the comma, period, semicolon mess. Elixir, much more comfortable to write. They're basically just the same thing on top of the Beam, right? On top of Beam, that glorious VM. Now, OTP, they both use, right? Because Elixir and Erlang both use this open telecom platform. So all the supervision trees, all of that stuff that you get in Elixir, all the message sending, which is just Erlang, well, part of the Beam VM, it's all the same thing. So we're just using that sort of mechanism right here. I do like writing Elixir much more than I like writing Erlang. I think the syntax is much more comfortable. Okay, so we need some sort of message and a type. Oh, and we have to give it that context, ctx.receive.await. Okay. We give it that first. The OTP model, yeah. Wasn't it? It was created by a Rubyist. I also like the, I remember liking the ORM. I don't remember if I still like it. It's been so long ago. The Elixir ORM, what was it? I thought it reminds me of like an octopus. I don't remember what it's called. Man, it's been so long. Ecto, that's it. Yeah, Ecto was cool. it's not going to be broadcast, so just have the message. And this is going to be, I don't know, static TCP socket? Standard. No, it's probably going to be a Tokyo. Oh, and we're not getting auto complete here. Tokyo net TCP socket. Just an owned type, no ref. Oh, of course, because it's being passed in, isn't it? You can't get a static ref without box leaking. Gotcha. That makes sense. And that's why in their example they were using strings. So, yeah. Static strs. Yeah, that does take a while. One of my favorite places to point people in that case, right, is going to be docs here. So Detolne published some documentation into crates. And I think this kind of explanation of the borrowing system really helped me. So take a look over that. It's not too much text. It's a short read. But it does help. Yeah, you're welcome. So we end up with that GL, a new thing we learned today. Oh. And then we have our block of code. I forgot where we were going. Okay. No. Here. Yeah, now we just do something with it, right? Let's just log for now. Rust is very different from C#, which you do professionally. It makes your brain hurt. Yeah. Tracing, just to make it visible. CUDA socket. Oh, what's going on here? Missing closing delimiter. Oh. One more? That doesn't seem right, though. Mismatch closing delimiter, okay. Yeah, it's here, right there. There we go. Okay, now what's it saying? Any code following this expression is unreachable. True. And what should we do there? So we're going to have this happen all of the time. Or we just have something run forever. Oh, import that. No rules expected the token @. Is this because... Why? Token @. What does that mean? Okay. Missing tokens in macro argument. Okay. While trying to match semicolon. Did we... didn't terminate the branch. Okay. Right there. Missing tokens in macro argument. Is it because I didn't include one of these? Okay, web doesn't have tracing or Tokyo yet? Is that true? Web cargo. It doesn't. Okay. We need both of those. On web cargo. There it is. The error messages in Rust teach you how to program Rust. They are amazing. LSP. Nope. Start. One thing I've noticed with Helix, it doesn't monitor like the cargo or the other changes that would normally require the LSP to be updated. Unused. Yep. How do you test Bastion? Huh. I think you would just fire it up, right? Like you would invoke this, send it a message, see if it responds, etc. So you would just run it. I'm looking at this thinking, goodness, how do I test this code? Ideally, we would get some sort of answer and not just that. Okay. Ignoring the test failures. Let's double check. All right. Cargo run -p server. Okay, undeclared use of crate. Must be restart. On to your day job. All right, I'll be following you in about, I don't know, about an hour 15. And thanks for hopping in. I appreciate it. Okay. So we are setting up this supervision tree. Saga supervisor. If the supervisor dies, start it alone. Why the redundancy? This thing is so simple. We could just have redundancy of 1 and it just restarts itself, right? Then we'll have another supervisor for those children. Because we can, yes. It was fun. I'm going to remove that. Because I don't see the need for it. As sockets are being connected, right, we might get a rush, but that's okay. We'll just work through the mailbox as quick as we can. Right? Adding these to this other supervisor. That seems like it should be able to do that relatively smooth. And I think having them done one at a time would be fine. That's what the upscaling strategy is for. Okay, where's the... I didn't see upscaling in here. Where do you define the upscaling strategy? Resize your upscale strategy. If the mailbox is too full, start another actor. If the mailbox is too low, kill the useless ones. Oh, that's lovely. Huh. Oh, with resizer. I don't see it here. Is it on the supervisor? No. Children with reset. Behind a scaling feature. Oh, of course, and it says so right here. I see. So let's add that. Web cargo. Bastion. Scaling. Okay. You know, use cargo add to add additional features. That's... I've done that before. Will append the feature? Gotcha. We have with resizer, and then we give it a scaling strategy. Optimize size, exploring resize. Whoa. Optimal what? Size exploring resizer? Wow. Did this not? Metric. Pending inbox message is too high. Add another pod actor. That is pretty cool, right? So you do that with, let's say, pathfinding or other things that have been expensive in my past. Did I spell that wrong? Feels like the LSP didn't restart. Oh, psychic coding. Thank you. Where does this exist? Bastion resizer. There it is. Okay. Now at this point, we want with lower bound and with upper bound. And what is upscale strategy? Going to be explicit here, with upper bound. Now in this case, we want the upper bound limit to be, in this case, let's say 3, right? Just to explore this, right? See what we can do with it. I am not expecting that this is going to be a hot pipeline, right? But we're learning this thing. That's really neat too. Especially considering that you can use this in a distributed way. Oh goodness. Oh. Text messages. All right, neighbor, gotta take this one. All right. Okay, so we have this set up, But now we need to be able to somehow wire Actix into this. Now, here we've called start, which is kind of neat, right? But we haven't started Actix at all. And that's what we're planning to do. We're planning to use Actix. No, excuse me, Axum. A-X-U-M, Axum. Okay, so let's go into the modules. Routing response handler, service ext, modules. Why am I not seeing server in the structs? You use this hyper thing to create features. Hold on. I'm going to take you on an adventure with me. My neighbor is basically offering a swap, a wood splitter and a generator. That could be something we do. What type of fuel does it take? 21-hour runtime. Because that could be useful, right? It's small enough to move around. Because really something that I want is something that's going to be able to power a lot more around here. OVH, so it's gasoline. Okay, thank you. So what I would prefer is... I would prefer a larger, I don't know, like a 10,000 watt propane generator. Something in that sort of class, right? Propane basically stores really well, right? It stores forever, 30 years or so. A microwave, yeah. See, we basically just a portable spa. That's it. That's what I need for the stream, right? Nice little portable spa steaming. Yeah. Water pumps, etc. I would like to have like a full power backup. Not like battery powered, right? But actually, I wouldn't mind having like a dual, right? You go to battery and then you can recharge it with the propane. Anyhow, side note. But the smaller one could be useful for, let's say, extended outages where we want to keep, let's say, Starlink powered, right? I have a UPS here at my desk. It says it could run me right now for about 500 minutes. Not bad. And then I also have the power in the laptops. But I think so keeping me on the job, right? Because we can work pretty well without power here. I can use fire. All right. All right, that's a little too much of a view into my life. Going back a little bit, thank you, Glitch. You can use a hyper thing to create futures that you just spawn inside new child. Copy link, let's take a look. And the make service is the router. Okay. Lower level configuration of the HTTP protocol. I see. This configures the connection. Oh, I see. Serve connections with executor. Okay. Pipe flush. Did you mean to link to a specific function? Serve connections. Bind a connection together with a service. This returns a future that must be pulled in order for HTTP to be driven on the connection. See. Axum server is a re-export of hyper server. Oh. Okay. Which takes a tower service, also re-exported. Oh, thank you, Nightshade, dude. Which gets pretty deep. Well, we're here to learn, so. All right. So, let's come back here. It's just an, oh, I see. It's here. Ooh. So, oh, wow, that is, sorry, I'm wrapping my head around that. That's crazy. Okay. So Axum server is just hyper server. We're binding to a specific place. Oh, wow. This stuff is moving to hyper-util. Soon hyper won't even have a server in it. Axum is just hyper with the fancy router extractor stuff on top. Oh, gotcha. Wow. Okay. Okay, so based on that, let's go to hyper server. I want to understand this a little better. The server's the main way to start listening to the HTTP request. It wraps a listener with a make service and then... Okay. Or his old slogan is function request response, which is basically a lot of fancy Rust for dealing with request response model. Protocol transparent. Interesting. Okay. So wiring this all together, we have Axum Live View, we have these different pieces, and really we want to be able to have the live view portion receive a message and update, right? But there might be many different live view chunks. Where was that? Bevy, child. Oh, did we have that local? We did, okay. So when we call mount, we want this sort of context loop. Okay. And we don't even know what this is going to represent yet. I just kind of imagine like health and regular stats, right? Kind of your vitality information, and then kind of a running log of what's going on in the world, right? A little command window at the bottom, or input, right? So you could enter your command. So how do we get these pieces connected to the Bastion pipeline? Because while it would be interesting to have each of the connections associated with Bastion, the utility is not quite what I was looking for. I think that it's useful, but maybe not in the way that I expected. Because we're really trying to wire up live view. Okay. Dang. Okay. Client and server APIs, low level, optional features. Perhaps a listener with make service. Yep, there's request response. Okay. Service, HTTP service is something that implements service of HTTP request v1 and response. Okay. So normally, Axum would manage all of the sockets for us. Actually, I can't even say that. So Axum is a router extractor stuff on top. So normally Hyper would manage the sockets. It's too low level. In Axum, you call into make service on your router. Oh. So I immediately went to, okay, we need to start listening to these sockets, receive these things, and then pass them into Axum. The router is a hyper service. Okay. Let me look at serve connection again. Oh. Yeah, router for tower services that happens to specialize for HTTP. I see. So it's really just part of the tower stack that adds routing, and there was some other stuff. Bind a connection together with a service. Okay. This returns a feature that must be polled in order for HTTP to be driven on the connection. I see. So we could do the polling inside of Bastion. Axum's at the top, tower is the glue, hyper is the bottom. Tower is the spice. So we create a new HTTP serve connection. Now, once we get to this point, though, and the service here is tower, excuse me, is Axum, right? Into make service on your router. Oh, I see. Okay, let me wire these things together. So, oh, that's on service ext. Oh, there's a number of them. We have router into make service. Oh, there's a bunch of these. So would we still set up Axum like the default way? So yeah, I guess, okay, so we need that. Let's open another tab. So we're not going to be doing the bind. We do the bind piece. That's just, excuse me, hyper server. Okay, so that's hyper. We're binding. Then we ask it to serve. And also have the router run different services on the same port. Okay. Basically, we can. This is on HTTP, right? So this is on HTTP, but where is it? Oh, this is a server. This is the HTTP server. So this is basically this thing, right? Well, we get back here, and then later we call serve connection on it. What's IO? Like, which is a builder for the HTTP server. Pour some more water. They used to be much worse. Goodness. Okay. So we need the result of this serve connection, right? But we need to be able to provide a connection. So we need to not have the server bind, but we bind, and then we ask it to manage a connection. MIO, some service. And this Axum server, all items. No, go back. Re-exports. Serve takes a factory and creates a specific HTTP 1.2 server that listens and invokes that service. All right, so in order to be able to take those connections and have them managed by Bastion, we need to do the listening so that we can provide the IO to the server then. Is that correct? Or am I still thinking too low level? Or builder. I'm going to have fun with that. And what is the benefit going to be then? We'll have the TCP connection that we could just shut down from Bastion. What does Bastion do? So it can restart services, and it does message passing. It provides supervision trees. Yeah, it's an actor framework. Okay. Yeah, I still have to... And this returns a connection. So service S. So we take self, we have this, and we have the service. And the service here would be, was what is defined in Axum, right? So when we create a service, being this router, right, that would be the second parameter to, you know, serve connection. This would be the router. It doesn't use Tokyo, so you'll have to run times of the... which one doesn't use Tokyo? Bastion does. Yeah, it has a feature flag, so... Let's see. Pretty sure you could integrate this Impel Tower service as a middleware for any Axum server. Agnostic. It utilizes Tokyo's I/O driver to provide I/O compat. Okay. So, just to throw mud at the wall here. Runs the matching handler, yeah. Oh, interesting. We're going to have... And can you do supervisors of supervisors? Alright. Let's look at Bastion's docs again. Nope, not that one. And other supervisors. Okay. You can spawn off the connection future into a child. Okay, so let's come back here. Okay, so we can do supervisor, supervisor. Creates a new supervisor, passes it through the specified. Okay, so we could do another supervisor here. I'm going to take this piece here, basically put it inside of a new supervisor, one that is still won't get the TCP stream in Axum. Not a problem. Just run your own accept loop with Tokyo TCP listener. Now, that's what I was thinking. The HTTP function is agnostic over the connection type, and Axum doesn't require a server. Right, it's just a make service. But the Axum extractor stuff is pub crate. So you'd have to make your own router. But the that function up here basically lets you bind the service. This serve connection lets you pass in the service, right? I think that makes bind service piece is the key. The serve connection, right? Because the third parameter here, well, second if we're not counting self, is the service. So that's the router. Right, so we could basically just provide the router here, right? That's a live view. Ew, that's a live view. But how do you get the response from the extractor into response from something like Bastion where you give it the TCP stream? You won't have the router state in those children. All right, so let's try to just push it forward. Supervisor. Oh, trying to clobber SP. This supervisor SP dot. Can we name it? With strategy with callbacks dot name. No. Okay. Fine. Oh, here. 1 for 1 on this? All for 1? That should be okay. Oh, okay. Handle half open sockets or whatever. Real. Well, the title is very witty. Still don't know what's happening here. Can anyone enlighten me? Hey, welcome. So we're building a mod. And at this point, we're discussing how we're going to... Okay, we're building a mod and we're learning Rust and Rust crates, right? The ecosystem at the same time. So the real Enrico Palazzo. At this point, we're... If you don't know what a MUD is, it's a multi-user dungeon from, imagine like internet in the 80s, right? You dialed into something, into a BBS, and you could play these online text games. And so we're bringing that back, right? But with a little bit of a modern spin on it. So we're building a web interface to an old school MUD. And we're discussing how we're going to be using these crates, Bastion and Axum, how we're going to bind them together in order to support pushing UI pieces to the client. To learn Bastion. That's the point, right? Like, okay, and yeah, you could by managing it with Bastion, maybe have a more global shutdown process. Assault's a rusty mod. Yeah, let's see. But don't panic in the future. That's right, we only panic in the present. That's curious though. What happens if you panic in the future in Tokyo? All right, so this supervisor here is going to be our top level supervisor. So the real Enrico, I hope that answers your question. If not, please ask more questions. Lumicode, how are you? Happy Thursday. And we got about 25 more minutes. But I think I see the way we want to do that. Oh yeah, most Rust programs can't handle out of memory. They're just not designed to run after OOM has been hit. So we're not worried about out of memory. Oh no, it's multiplayer. Yep, multiplayer. So many connections. MUD is a multi-user dungeon. Yep. All right. So this piece here, interesting. Okay, this was fun to write, but I don't see its utility at the moment. What does this do? This waits for a message. We might not be able to use this. Okay. So let's spawn something new on the supervisor. And we're learning Bastion at the same time. Old school cool, made cooler because it's Rust. Precisely. That's our goal here. And to learn Rust, right? And the tools in the ecosystem. All right, so we have our supervisor. Now let's have our connection handler. Whatever it is, connection handler is supervisor dot. Ooh, children. We could do children here, can't we? And we get context here. Okay. Yep, so then we get our children, we can do it with exec, etc. Okay. Now in here we could do with exec. We could also do name here. Web listener. Redundancy. We don't want redundancy on this. We want one only ever. With exec. Now here we get the context, don't we? Yes, with exec we get context. Now at this point, we return async move, right? Something that will be run. And in here we'll have our Tokyo socket listener. And when we get a new socket, we will use that HTTP bind with blah, blah, blah piece to attach an Actix router to it. Okay. Oh, you wanted to box UA 5 megabytes? Oh, and you blew the stack. Okay. So now we have this async move. At this point, what are we planning to do? Let's add some comments. Listen to port 80,443. I don't know, probably 443. We'll need to get that from somewhere. Have to Bastion to manage. Okay. And so at this point, we're going to do a TCP listener in Tokyo. So we'll do Tokyo net TCP listener bind and then accept. Yes, so we bind to, hold on, full accept local header. I think we would bind to a specific port. Let's just do 80 or 8080 because, you know, machines, whatnot. We'll need to get this from the socket or from a config. Okay, dot await. let listener equals that. Now we can loop on the listener. No, while let sum is equal to listener dot accept. Okay. Oh, I see. And we got the TCP stream and the socket adder at the same time. Do we need the socket adder for anything? I don't think we do. We want dot. Hey, what was that? No. Space K, space shift. I'm learning Helix, a new editor. My Vim fingers take over occasionally, and trying to hit K. Option unknown. Okay. Oh, look at that. Okay. Returns a result. So we can't do the while let sum here, but we could make a one-shot per request, send the data in the center to Bastion. Bastion writes to it, and Axum waits the one-shot for the response. Just return an error. Yeah. Yeah, if we just return the error, then it'll restart, right? So in this case, just do that. So we don't need the while let, because it will bail out and restart it. So in this case, VT equals, see, loop. Oh dear. Let, was it socket? Socket adder equals that. Okay. Then we do something with this. Yeah, I'm planning on per connection isolation. Okay. Yeah, I know. I know. Oh. We could give the type hint for this in the return value, right? So let's just match on that. Match. one case we'll have what, okay, and then socket in, sock adder. And what do we get for the error here? Do we care? Metrons have incompatible types. Okay. Oh, the result needs to be unit. Okay. We can log this. Oh, come on, fingers. Tracing error. Could not bind to. Okay. How do we include this? Okay. So we could still include the error in this. Okay. Now the listener, we also need to manage the error. Oh, what's that? What's that other binding? Let else? We could do a let else here. And how do you do a let else again? Else diverging block. Okay. Oh, let that bind. Otherwise, boom. Okay. So here, else we do this. Okay. Okay, and the message is wrong here. Oh, it doesn't handle the else. Oh, okay. Thank you. Yeah, that was confusing me. There we go. Or even just a map error. Yeah. With the map error, though, we would still need to trace inside of the map error. Then I wanted the tracing to be, I guess, more clear. Okay. Yeah, the only yeah. Okay, that looks like it mostly works. Okay. What's going on here? Supervisor moved due to this method call. Supervisor really. Oh. So we need to have another supervisor? Ah. What does children return? That just returns children. Okay. Why did it move? Oh, thank you. Expected this to be unit. Expected what to be unit? Return type inferred here to be unit. That's fine. Oh, children consumes a supervisor. Children ref borrows it. Is there a supervisor ref? Oh, okay. A ref. Thank you. And this here. Unit. Expected unit type found enum result. Why is it expecting unit? So with exec, it's expecting the output of this future to be result of unit. Maybe here? Oh, because here we don't have a return type. I think it should be able to figure this out. And why is it not using, like, checking the web piece? Cargo. Web is there. We're currently working on web. Oh dear. Okay. Because we're not returning. It's not the last thing. That's why. So if we returned... Right. And at that point, it should know it. Okay. And we need to do something with the sockets. Fine. Okay. So at this point, we take the socket, toss it to Bastion, and somehow we will take and use this serve connection here. Finds a connection together with the service. And then we will simply pull that connection in order to keep it, you know, driven. Okay. All right. Now, at this point we have the socket. How do we add a child to a different supervisor? Let's say we want to have, here we will have a connection supervisor. And once we receive that, we'll put this thing here onto that connection supervisor. Patch panic future wrapper. It's basically just a future that pulls the inner future. The only difference is that the pull is done inside a closure that's passed to panic. Catch on wine, I see. You are over-engineering your own stuff again. Okay, so we'll have this connection supervisor, and then we will attach something to that so that it can be run over there. Oh my goodness. Use HTTP serve connection. All right, that's the plan. We'll pick up on that again tomorrow. Oh, but thank you for hanging out. I need to run. This is interesting. I wonder how it's going to work. I really do. The stream is looping back upon its tail here. It's about a 3-year loop, 2.5-year loop. Okay. Search for Rust. Rust. Possibly unsafe Rust. Alright, sorting. Tej, Rust plus Neovim. Interesting. Let's write Tej. Probably somewhat and barely. Well, thank you all. Till next time. Bye-bye.